Good afternoon, good evening, or good morning, wherever you are. Thank you for being here today for our presentation on a new MPAI standard, neural network watermarking technologies. First, who is MPAI? Leonardo, if you want to present
Oh,
that.
you can do it.
I do it. So MPAI, it's moving picture, audio, and data coding by artificial intelligence. That is an international, unaffiliated, not-profit association based in Geneva. We develop standard related to the efficient usage of data and specifically technical specification for coding of any type of data and for technologies that facilitate integration of data coding and decoding components in information and communication technology system. Our target is to bridge the gap between technical specification and their practical use. We are considered as an actor operating on open international collaboration basis, and we are committed to support our partners in doing so. Although quite young in the landscape of standardization bodies and the open standardization bodies, MPAI have already successfully finalized various standards related to AI, and the approach it's both vertical and horizontal. So we have standards related to the very orchestration of AI applications, like AI framework, for instance, or profiles for AI applications, and application domain oriented, like AI for health, automotive, finance, human machine communication, multimodal conversation, and so on. Of particular interest today are the standards related to neural network watermarking and traceability that can be seen in this line of the slide, of the third slide. So neural network watermarking, neural network traceability, and neural network technologies. Why standards on neural network traceability? Neural networks today, it's maybe one of the most frequent pronounced idiom in the field of science, of technologies, and till politics and governance. Both academia and industry contributes a lot, but I would like to draw your attention today about three specificity of neural networks. First of all, by their very definition, they are supposed to behave autonomous and without human intervention. And this in application domains that can be critical. We put on this slide, just for illustration, the use of AI in a medical application where human life is at stake, or in autonomous vehicle driving, be there passengers in these vehicles or passengers or humans around that vehicles. Secondly, beyond being used in fields that can be critical, neural networks are expensive. And I tell this word as an academic guy. I tell this word in its broadest acceptation. Expensive here means that in order to have reliable neural networks, you need human skills. You need scientists to design and to deploy these models. You need humans to create application-relevant database, to organize this database, to clean them, to curate them, to store them. You also need hardware to run these algorithms, and you need also skills for building operational workflow on the top of trained neural network. So it's a costly field applied in critical domain and also applied in on workflow on which various human interacts. So for the same task, multiple neural network can provide an inference. So identifying the models that actually produce that inference, it's important. When shared among multiple users, keeping track of the distribution of the acting process on how each user interacts with the model or in its inference, it's also important. And when models or inferences are modified, they are attacked maliciously or by error, this should be identified at once. So neural networks traceability and integrity caters for the needs of neural network usage in complex workflows where both authorized and malicious operation are performed on these networks and on their inferences. What is our standard about? It deals with two types of traceability technologies, the so-called active and passive techniques, namely watermarking and fingerprinting. Let me introduce you these two concepts. Watermarking is inherited from the multimedia realm and makes it possible for some data, mark or a watermark, to be imperceptibly and persistently associated with a neural network model. Why we use these words, imperceptibility and persistently? Imperceptibility means here that the watermark model, the model that was modified for traceability purpose, has the same functional properties as the original one. And persistently means that the watermark can be recovered not only for the watermark model, but also for the version of this model, for the derived models that still have the same functional properties. Why this field is of interest after years, while decades of research studies for multimedia content? It's because neural network watermarking has its own specificity. It's no longer a static process, but it's a dynamic. Generally, the watermarking it's bind with the model training, or at least with the inference generation. And because the evaluation of the watermark impact is even closer related to the application scope and to the application workflow of the model. Going now to passive tracking techniques, so techniques that do not modify the content, we speak about fingerprinting. And as shown some 150 years ago, human can be identified starting from tiny information extracting from their fingertips, these ridges and edges and their combination and angles are able to unambiguously identify a person in a database. Neural network fingerprints are much alike. They are teeny information records from this neural network, so really marginal with respect to the size of the model itself, that allows for the model to be identified when used in its original version, even when it was modified by common operations such fine tuning or pruning or transfer learning. So our standard deals with neural network watermarking and neural network fingerprinting, and it's including in the family of standards MPAI devoted to that. We started our work some 4 years ago in January 2022. We released our first standard 1 year later, so MPAI promoted in January 2023. I apologize. Promoted in January 2023, its standard technical specification NNW, sorry, that became later the same year an IEEE standard under the reference P3304. We continue with fingerprinting application and standard grouping both watermarking and fingerprinting. It's called MNT, Neural Network Traceability, that was promoted by MPAI November 2024, and action towards its adoption by IEEE started right away under the number 3309. This third standard in the MPAI family, NNW TEC, was progressively built based on the results of the call for technology released by MPAI in June 2025. What is the scope of the new standard? The scope of the new standard is to use its previous related standard. Neural network traceability and neural network watermarking technical specification to evaluate the properties of neural network traceability technologies that are applicable to specific classes of neural networks and used in specific application domains. Evaluation are done in order to verify that the data provided by an actor and received by another actor it's not compromised, and to identify the actors providing and receiving the data. Of course, we evaluate the performances, the technical performances of the solution supporting the points 1 and 2 above. By actor, we understand the process that provides, processes, or consumes information, and of specific interest for the standard are the architect, the trainer, the tracker, the distributor, the attacker, and the generic users. So the architect is the one who designs the architecture model, and it's involved much in watermark insertion, and its knowledge may influence later modification. The trainer is the one that trains the model, and it's active it can be active during the watermark embedding, and sometimes might perform update on model, both unwatermarked or marked model. The tracker is the actor that provides and verifies tracking technology. The distributor is the one who deploys who operates the distribution flow of the watermark models. The attacker, it's the one who applies modification to the watermark models, but keep in mind the attacker can be malicious or not. This attacker can be even the owner that needs its watermark model to be fine-tuned or to be embedded into some hardware device, and these are just some two examples. Uh, uh, be it malicious or not, yet the attacker action can result in removing IDs, in misleading authentication, or in creating some kind of watermark ambiguity that can be exploited by malicious users through some protocol attacks. The generic user is the authorized user that operates under the distributed service agreement. To illustrate, today we consider NNW Tech applied to three technologies. This slide presents you the references. Keep in mind that all our efforts are done in order to keep this standard open and directly applicable. So don't consider these three technologies as some limitation or some predilection for the standard. They are just here to show how the standard can be used. And we selected here technologies that are widely used widely known in the state-of-the-art study, or that are new and present some particular application. What we created for the current version of the standard, we created several application domain. As you see here, we consider classifier like VGG16 and ResNet 8 for image classification. We consider PIX-to-PIX generative task and RDN upsampling on div2k and on DibLab version 3 image segmentation. The databases, we tried as much as possible to consider them to be the widest known by a community. Of course, it's always difficult to state that, yet the software resources we created and the standard specification are not limited by the databases. The same, the performance, we consider performance applicated to the task. For instance, if we go towards classifier, we go to top 1 accuracy, but you can consider the also top 3 accuracy or other type of measures. And if we go, for instance, on segmentation, we can consider mean intersection over union and other measures like this. We evaluate the impact of the watermarking process as a relative error between the performances of the unwatermark and the watermark model. And when I say relative error, it's absolute difference, and the relative, it's with respect to the unwatermark model. So this is the definition of impact. We create and we present detailed tables for each type of method and each type of attacks as included in our previous version of MPAI NNW standards. And of course, going through all these results, it's far beyond the time we have today. The standard goes more than that, yet cannot be exhaustive. But with the software resources and with the previous specification, each user can create the lines of interest for its own applicative field. So we evaluate imperceptibility, we evaluate robustness, and we evaluate computational cost for these three methods. Please don't hesitate to go and to visit our MPAI resources. Don't hesitate to contact the community manager and to join us for sharing your interest in the standard and of course in the standard as it is today, but our standard is captured just an instance of the technology status at a given moment, and we are also very interested in exchanging on the future of this standard because it is meant to be kept open and evolving. Thank you very much.